So, good evening. For the definition of Dalton's law of partial pressure. So, it states that the total pressure of a mixture of gases is the sum of the partial pressure of its component. So, what does it mean? So, it means that the total pressure by a mixture of gases is equal to the sum of the partial pressure of each of the constituent gases. So, the partial pressure is defined as the pressure that each gas would exert if it alone occupied the volume of the mixture at the same temperature. So this empirical law was observed by John Dalton in 1801 and published in 1802. Dalton's law is also related to the ideal gas law. So as you can see, pressure total is equal to P gas 1 plus P gas 2 plus P gas 3, where the partial pressure of each gas is the pressure that the gas would exert if it was the only gas in the container. That is because we assume that there are no attractive forces between the gases. So for example, oxygen and nitrogen. So the measurement of the oxygen's pressure is equal to 159 and the nitrogen's measurement of pressure is equal to 593. The two gases were added together and it is the total pressure that they have, which is the 752. So Dalton's law of partial pressure can also be expressed in terms of the mole fraction of a gas in the mixture. The mole fraction of a gas is the number of moles of that gas divided by the total moles of gas in the mixture, and it is often abbreviated as X. So X1 equals moles of gas 1 over total divided by total moles of gas. And Dalton's law can be rearranged to give the partial pressure of gas in a mixture in terms of the mole fraction of gas 1. So pressure gas 1 is equal to X1 times the total pressure. So let us have Mr. Mahusay to expand everything.
A jar contains 425 kPa of carbon dioxide and 750 kPa of nitrogen, and the last is 525 kPa of oxygen. What is the total pressure of the container? So, in order for you to get the total pressure is you just have to add all these given gases, which is the partial pressures. So let's start with the first one, the 425 kPa of carbon dioxide. Then let's add the another one, the 750 kPa of nitrogen. And the last one would be 525 kPa. So all you have to do is just add all these partial pressure gases. So here is your here is your total pressure gases, which is 1,700 kPa.
Example 2. A mixture of nitrogen, oxygen, and neon gases exerts a total pressure of 893 torr. If the mole fractions of these three gases are 0.41, 0.35, and 0.24 respectively, what are the partial pressure of the three gases? For example, P gas 1 is equals to X1 times P total. Pn2 is equals to 0.41 times 893 torr is equals to 363 torr. P02 is equals to 0.35 times 893 torr is equals to 313 torr. PNE is equals to 0.24 times 893 torr is equals to 214 torr. Total of 893 torr.
Example number 3 is if a mixture of gases contains 7.50 grams of hydrogen, 3.25 grams of oxygen, and 5.55 grams of nitrogen. What is the mole fraction of each gases? So, to get the mole fraction of each gases is first you need to convert grams to moles. So to convert grams to moles, place your 7.50 grams of hydrogen and multiply it by 1 mole of H2 divided by 2.02 grams of H2. So cancel ang grams H2, and ang pagkuha sa kaning 2.02 is molar mass ra sa element sa hydrogen. Ang molar mass sa hydrogen is 1.01. Multiply it by 2.02. So 7.50 divided by 2.02 is equals to 3.71 moles of hydrogen. Same goes sa uban. 3.25 times 1 moles of O2 divided by 32.0 grams of O2 cancel equals to 0.102 moles of O2. 5.55 grams of nitrogen, multiply it by 1 moles of N2 and divided by 28.0 grams of N2, cancel na sa dang grams, so equals to 0.198 moles of nitrogen. So after converting, mauna ni ang grams to moles. So mo ni mong kinahanglanon. So step 2 is to calculate the total moles of gas. So to calculate, igo ra nimo sila ipang-add tanan. There goes your 4.01 total moles of gas. Step 3 is to calculate the mole fractions of each gases. So to calculate the mole fraction of hydrogen, first is get the mole of hydrogen, which is 3.71, divided by the total moles, which is 4.01, equals 0.925 moles of hydrogen. So this is your mole fraction for hydrogen. To calculate the oxygen, mole fraction of oxygen, buhaton, same rag buhaton. So 0.102 moles of oxygen divided by 4.01 total moles is equals to 0.0254 moles of oxygen. Calculate the mole fraction of nitrogen is 0.198 moles of nitrogen divided by 4.01 moles of total moles equal to 0.0494 moles of nitrogen. So this is your mole fraction for nitrogen.